Welcome back. In this video, I'm continuing Leetcode 75 problem list, and today that's problem 605, can place flowers. So we have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where zero means empty and one means not empty, and an integer n return true if n new flowers can be planted in the flower bed without violating the no adjacent flower rule, and false otherwise. Okay, example one, we have this flower bed and one flower to plant. We can plant it here, so this is true. Example 2, we have this flower bed. It's actually the same, so we can't plant two flowers in it. Let's try to code this up. My approach to this problem is to think of perfect planting configuration and then and check what's the maximum number of plants we can plant that way, and then reduce that number when we check what's currently planted. If that way of planting is not in line with the efficient planting, or how would I say it? I'll code it and explain it while I'm coding. So first thing, we need to find what's the number of spaces we have in flower bed, so we can find the maximum number of flowers we can plant. So spaces is line of flower bed. Okay. Now that we have length, excuse me. So now that we have length of flower bed, the maximum number of plants we can plant is equal to spaces divided by 2 minus sum of already planted flowers. That's the first part for calculating. And now we need to now we need to add to the maximum in case of odd number of places on the flower bed, because let's check this example. In this example, we have 5 places. If we use this logic, we would have 5 divided by 2, it's 2, so integer division, minus sum of flower bed is 2, so that would be 0. But actually we have one place here if we have this kind of configuration, if we planted on the first place. So so that's part for the odd number. But let me also show the example for the even number. If we had something like this, so 6 places, we could, if we calculate it, so maximum would be spaces divided by 2, so that's 3 minus sum is 2, so we would have one place to to plant, and that's true. We can plant here and here. So but one thing to note, when I'm looking for the perfect planting configuration, I'm always looking to start from the 0th index. I use this logic for modularity a bit, but let me show you like this. So in this same case, if we had something like this, so 0, 1, 0, 0, 0, this is 6 places if I'm correct, we can still plant here. And so for this situation, we actually can have one change of configuration, meaning, I don't know, I'm not sure if I have said what configuration is. So configuration is planting from the, so current perfectly planting from this position, let's say it like this. So if we started like this with 0 here, perfect planting would be here and here and here. If we had one more change of configuration, meaning something like that, this, we would lose we would lose actually one place in here. So, and that's because, but if we started here, so 2 changes of configuration is equal to, let's say, one lost place. And why is that? Because each time we change configuration, we shift everything we can plant, our initial perfect configuration, by one place to the right. And because, like in this situation, so it's like this 0 0. So we are following perfect configuration. In this case, if we planted here, we shifted everything by one position, because if it was here, our next one would be here. So we lost one place. And every 2 lost places is actually losing whole place to plant. Meaning if we had maybe something like this, so this is first change. Yeah, I messed it up a bit, and this is second. I hope it makes sense. So what I'm going to do now is to add the maximum 1 if we have odd number of places. So spaces model 2 is equal 1, else I will add 0.5, because in even case, in the case of even places, so let me show it once more. We can actually, if we start from this configuration, we can have one change of configuration to still be able to plant maximum number of flowers. So if we have one, it's okay. So yeah. Next, I hope it makes sense. Now we say configuration is true, so we are looking for to start from the 0th index. And now we need to check our flower bed. So for I in range basis, what do we need to do? So if our maximum is less than number of flowers we need to plant, we return false. If that's not true, then we need to check if we are following efficient or perfect planting in this position. So if conf is equal to true, this means we are always planting on even index, or on the index where index modulo 2 is equal to 0. So on the 0th, then one is empty, then on the second, and so on. So if configuration is true and our position is even, so should be empty, and our flower bed of I is equal to 1, we need to change our configuration. So in this situation, efficient way of planting from this position on would be to plant on, always to plant on even indexes. So we need to change our configuration false, and we need to reduce our maximum by 0.5, meaning we lost one space, but 2 spaces is equal actually to 1 planting space. So this, and we need to do it for other way around. So if configuration is false and we are on even index and flower bed is equal to 1, we again configuration to true and reduce our maximum. In the end, if we haven't already returned, then we return true, because we can. Let's run this. Accepted, submit. And as you can see, it's pretty efficient. Time complexity is O of n, so we only have this for loop. And space complexity is O of 1 because we don't have any list or something. So yeah, I hope I made this approach clear. Thank you for following and see you in the next video.